Today we're going to learn about rate of change. Rate of change is the ratio that describes the relationship between the changes of two quantities. Now, when we refer to the rate of change, it's often described as the change in y over the change in x. How would we describe the change in y? Let's take our first example, where we have a certain number of cards and the cost of the total cards. If we have one card, it's worth $20, two cards is worth $40, and three cards is worth $60. So let's take the interval from 2 to 3. The way we would find the change in y for this example is the change in cost, because y is equal to cost. So what's the change in cost? On this interval, we're going from 40 to 60. The change in cost would be the difference. So 60 minus 40 is the difference. What's the change in x? It's the number of cards. We go from 2 to 3 cards. So the difference would be 3 minus 2. And this would be 20 over 1. So what can we conclude about the rate of change? Is that for each card that we're adding, the cost increases by 20. And we see that very clearly because the change in cost goes from 40 to 60, and the change in cards goes from 2 to 3. So for a change in cards of 1, we have a change in cost of 20. The rate of change can be linear or nonlinear. Linear means the rate of change stays the same. So in this first example, we go 20, 40, 40, 60. The change is 20 each time. And from number of cards, it's 1 to 2, 2 to 3. So the change is also 1. How about this second example? This one, the change in y is from 60 to 122. So that's going to be a difference of 62. And then 122 to 150. So that's going to be a difference of 28. And we go 1 to 2, 2 to 3. The number of video games stays the same, but the number of hours should also be the same, and that's not the case. So the rate of change is not linear. Thus, we can't simplify the rate of change for the second problem. We can define the rate of change between the smaller intervals, but we can't generalize it. So we have a change in weight from 600 to 1050, which is going to be a difference of 450. And we have a change in weight from 1050 to 1350. That's a change of 300. Now the number of apples here is going to be 4 to 7, which is a change in 3, and 7 to 9, which is a change in 2. Now, although the change in x and the change in y are different numbers, let's see if the ratio is the same. So the change in weight is the y and the number of apples is the x. So the change in weight, let's take the first interval from 4 to 7. So the change in weight is 600 to 1050. So we're going to take the difference. So 1050 minus 600. And the number of apples goes from 4 to 7. So the difference is 7 minus 4. So we're going to get 450 over 3. And this simplifies to 150. How about the interval from 7 to 9? The interval from 7 to 9 is going to go from 1050 to 1350. So the difference is going to be the higher number minus the lower number. And we go from 7 to 9, so the difference is 9 minus 7. This is 300 over 2. And that's also 150. So because the rate of the change between the two intervals is the same, we can actually say this is a linear relationship. So let's summarize here. For the first table, so we found the cost over the card, or the cost per card, is 20 over 1. And it's $20 for one card. The second example is not a linear function, so we were not able to generalize it. But the last function, for every 150 grams, that is the weight of one apple.